Okay, so the last video for this worksheet, we're going to do kind of some application problems. But before we jump into those, just remember for this worksheet, we've done quite a bit. We've looked at solving equations using the two properties together, the properties being the multiplication property of equality and the addition property of equality. We also looked at solving multi-step equations. We looked at clearing fractions, which is super duper important. Make sure you know how to clear fractions. We also looked at clearing decimals, it can be handy. It's not super magical though. And then we talked about classifying equations. We classify equation based on the type of solution. So remember, we had three types of equation. The first was a conditional equation that has just one solution. The second was a contradiction equation, which has no solution. And the third was an identity equation that had infinitely many solutions. Okay, so let's go ahead and talk about topic 6 and 7 in one video. Okay, so we're going to go back to this idea of direct translation. We've touched on it briefly in a previous video. Direct translation is the process of converting words to math. That's very, very informal, but we're basically going to take some kind of sentence, some kind of words, and we're going to convert them to expressions or equations. Some common words or phrases that translate to equality, since we're talking equations, we need to have that idea of equality here, would be equals, yields, is the same as, is equivalent to, is, gives, amounts to, and I think I meant to put etc. and I just forgot. So there's a little bit of a typo here, but I think the point is made. All right, so example 6, it says translate each sentence into an equation and then solve. So we want to first look for some word in these two examples that would indicate equality, and we've got several of them listed up above. So for part A, it says the sum of a number and 3 yields. Yields would be our equal sign. So the sum of a number and 3 yields -6. So that's where our equals is. So let's just make note we have an equals. Anything prior to yields is going to be the left-hand side of the equation. Anything after yields is going to be the right-hand side of the equation, okay? Now, we also need to assign a variable. So that's a big part of what we do with direct translation. When we're talking about direct translation, we have to generally assign some kind of a variable, okay? And you always assign the variable to what you don't know. So if I go back and I read this sentence here, it says the sum of a number, I don't know what that number is. So the sum of a number and 3 yields -6. Well, the variable would need to be assigned to some number. Usually any letter from the alphabet, generally you'll use X's and Y's, T is common, N is common, P is common. But for me, I always just use X. So I'm going to assign X to this number. So I want the sum, which means add, of some number X and 3. So I would just take X plus 3. All right, that quite literally translates to, if I was going from math to words, that would translate to the sum of a number and 3, okay? Yields equals -6. And now you have a quick, simple equation that you would need to solve. So remember, when we're solving equations, our goal is to isolate the variable, okay? We want to get the variable all by itself. And in this case, we have a single variable, but 3 has been added to it. So that plus 3 is an issue. The way we would undo plus 3 is subtract. Remember, you're always undoing what has happened to the variable. The variable's been added to 3. We want to undo that plus 3. And also remember, you must maintain balance. So if you do something to the left, you must also do it to the right. So I'm going to subtract 3 from both sides. On the left, I have +3 minus 3. That just equals 0. And as mathematicians, once you get kind of into the hang of this, you get really lazy and you're like, oh, things just cancel. You have to remember, yes, we say things cancel. We do it all the time. But things don't just disappear. Things cancel in algebra to be 0 or to be 1. In this case, 3 minus 3 is 0, so we would say the 3's cancel to become 0. And then x plus 0 is just x. And then on the right, if you haven't mastered your adding and subtracting of signed numbers, keep working at it, but -6 minus 3 is -9. So when we talk about the sum of a number and 3 and it yields -6, that number we now know to be -9. Okay? Let's look at part B. Part B is a little bit more involved. It says 6 times some number. We don't know what this number is. It's going to be a variable. But if we take 6 times some random number and subtract 8, so decreased by 8 means subtract 8, it is equivalent to 3 times that same number, but increased by 7. Okay? So we've got our equals. Anything prior to is equivalent to indicates the left-hand side of the equation. So we want 6 times some number, we're going to call it x, and then we want to decrease that by 8. So we get 6x minus 8 equals, and then anything after is equivalent to is the right-hand side of the equation. So after the words is equivalent to, we have 3 times the same number. What they're saying is 3 times the same number. They mean use that same variable, okay? Since we use x for a number, we're going to use x for that same number over here. So we want to take 3 times that same number, but this time we want to increase it by 7, okay? So now we have a multi-step equation. We need to first always get your variables into a single term. So you do all of your simplifying, do the best you can there, but you want to get your variables into a single term. So I like to move my variables to the left. Of course, I could move my variables to the right. I would end up getting the same answer, but there's an awkwardness to it. So you'll typically see math people move their variable to the left. So since on the right-hand side, I have positive 3x plus 7, that's like the same thing as 7 plus 3x, so I'm adding 3x. In order to move that 3x, I would need to subtract it. And in order to maintain balance, I would need to do that to both sides of the equation. So I'm going to start by subtracting 3 from both sides of the equation. On the left, 6x minus 3x is just 3x. Don't forget your minus 8 and your equals. And then on the right, 3x minus 3x is 0. So again, we would get lazy and be like, oh, the 3x's cancel. Sure they do, because they have a sum of 0. And then 0 plus 7 is 7. So we've made a good positive step here. We've gotten the 3x alone. So we've got all of our x's into a single term. We now need to get that term alone. The issue now is minus 8. So how would I undo subtraction? I would use addition. So I'm going to add 8 to both sides. On the left, negative 8 plus 8 is just 0. 3x minus 0 is just 3x. On the right, 7 plus 8 is 15. All right. And then finally, we've got a single variable term equaling a single constant term. This is when you apply the multiplication property of equality. We need to undo the multiplication of 3 and x. So to undo multiplication, we divide. So I would divide both sides of the equation by 3. 3 divided by 3 on the left is 1. And again, as mathematicians, we'll be like, oh, the 3's cancel. Yeah, they do. But they cancel because 3 divided by 3 is 1. 1 times x leaves me that plain x. So again, those 3's don't just disappear, okay? And then on the right, 5 divided by 3, or sorry, on the right, 15 divided by 3 is 5. So that number, that mysterious number in this statement is 5. If I take 6 times the number 5 and decrease it by 8, it is equivalent to 3 times that same number 5 increased by 7. Okay? So get in the habit of that direct translation, because in the next couple of worksheets, we're going to do a lot of direct translation. Okay? Finally, we have just an application problem. So generally in math, when you see the word application, think like word problem. Okay, so here it says use the information given to answer the following questions. Well, the information given to us is that the cost of speeding fines in a certain state are determined by the formula C equals 10 times, in parentheses, M minus 65 plus 50. And it then goes on to tell us C is the cost of the fine in dollars, okay? And then M is the miles per hour that the driver was driving. So C is the cost in dollars of the fine if a person is caught driving M miles per hour. Okay, so let's look at part A. If a fine comes to 220, how fast was the person driving? Sorry, hold on. Well, the fine is going to be C. So remember, C is the cost in dollars of the fine. So we're going to take this formula right here, but we're going to replace C with 220 and then solve for M. All right, so in order to solve, the first thing I want to do is distribute. So I'm going to distribute my 10 through M minus 65. So I get 220 equals 10M minus 650, and then don't forget the plus 50. And at this point, you want to combine like terms as best you can. You want to get the simplest equation possible before you start moving things left and right. So remember, your goal is to have at most 2 terms on each side of the equation, 1 variable term and 1 constant term on the left, 1 variable term, 1 constant term on the right at most before you start adding and subtracting on either side. So let's combine like terms. We have negative 650 plus 50. If I were going to combine that, I would just get minus 600. So negative 650 plus 50 is negative 600. We would write it here as minus 600. Now, I want to get my 10m alone, and this is an example where we'll generally just leave the variables on the right for now, but then when I write my final answer, I'll make sure the variable's on the left. So let's go ahead and isolate the 10m, and I'm sure some of you have just been dying to leave something on the right, so we're going to do it now. The issue with 10m is this minus 600. So I want to move the minus 600 by adding. All right. Well, on the left-hand side, we get 220 plus 600, which is 820. And that's going to equal just 10m because negative 600 plus 600 just cancels to become 0. So 10m minus 0 is just 10m. And then I want to divide both sides by 10. On the right, 10 divided by 10 is 1, which leaves me with 1m. On the left, 820 divided by 10 is 82. So here's where I would finally flip it. For my final answer, I would say m equals 82 miles per hour. And you could also say something like the driver was driving 82 miles per hour. It is very common to write your answer with a bit of a description. So at the very least, you need to say m is 82 miles per hour. That unit describes it. It's even better if you can write it in a little sentence like this: the driver was driving 82 miles per hour. All right, part B is almost identical, but in this case, the fine is $310. So I'm going to replace C with 310. So we're going to distribute again. So I get 310 equals 10 times m minus 10 times 65, which is negative 650. Don't forget your plus 50. Just like in the previous example, the negative 650 plus 50, they simplify. So I get 310 equals 10m minus 600. Okay. I want to get the 10m alone. And again, I'm just going to leave the 10m on the right. I'll rewrite it in the next step. So the issue with 10m is this minus 600. I want to move the 600 by adding. Well, 310 plus 600 is 910, and that equals 10m because negative 600 plus 600 cancels. Okay. And then finally, to get the m alone, I would divide by 10. 10 divided by 10 is 1m. And then 91 or 910 divided by 10 is 91 miles per hour. So at minimum, that should be your answer. You should at least describe what that number is. That number is miles per hour. It's even better if you could say something like the driver was driving 91 miles per hour. Always describe your answer with a word problem, okay? So it is really important that you practice everything we've done in this worksheet. So using the properties together, especially solving multi-step equations, you need to be really solid at that. Make sure you know how to clear fractions. Clearing decimals, it's okay. Make sure you know how to classify equations and really get some practice with that direct translation. You're going to see a lot more direct translation coming up soon, okay?